All right, hello. We're talking about lesson 4, and before I go through the material, I need to show you a short, to the point video on how to work the problems. So let me pause here for a second. Okay, I want to move over here. I hope you can see this okay. Um, let's review this for a second. 1/3 plus 1/3. Well, we know how to do that. That's the bottom numbers are the same, so that's just 2/3. 1/3 plus 1/3 is 2/3. We get that. All right, let's look at this. 1/2 plus 1/3. Well, before we do that, let's look over here. Now, you could do the same thing instead of with arithmetic, you could do with algebra. So we have the same denominator. The denominator is 2y, and we're going to add the top, x plus 21. So x plus 21 over 2y. All right. Now notice over here in this problem, back to this problem, we have two denominators that are not the same. Now you remember how to do this. Old school was you draw a column and you put them in a column. Let me just do this. We know the common denominator is 6. So I'm going to multiply that by 3 over 3 and 2 over 2. Won't that give me 3 over 6 plus 2 over 6? And then it's just like this first problem I gave you, and that's just 5 over 6. That's pretty straightforward. So that was one way to show you how to do that. I want to show you another way how to do that. So let me just sort of walk that back here, okay? So I want to show you the second way. Same process, it's just there's a little shorthand to it. All right, now notice that I have a common denominator of 6. I'm going to put that here. And then I'm going to ask you a question. What is this factor missing that this factor has? Well, it's missing a 3. So multiply the top here by 3. 3 times 1 is 3. Okay, let's do that again. What is this factor missing that this factor has? Oh, it's missing a 2. So you're going to multiply the top there by 2. 2 times 1 is 2. Notice I get the same answer I had by working out longhand. I have 5 over 6. I hope that makes sense. Now, over here, look at this problem. In this problem, notice the denominator is the same. It really goes back to this first problem I gave you. The bottom's x plus 1. Okay, let's say at the top, x plus 1. So that's x plus 1. Hey folks, doesn't that simplify? Anything over itself is simply what? 1. Okay? So again, we're adding not numbers now. We're adding algebraic expressions or rational, right? Rational expressions. So keep that in mind. That was pretty easy. I think we get that one. So let me move that out of the way. Now we have a problem here to the right. I don't know if that screen just messed up here, but now we have a problem over here to the right. So I need a common denominator. Well, let's see. I've got an x and x plus 1. That's a factor, and I have x. So the common denominator would be x times x plus 1. All right, so what is this missing? Well, this is missing that x. So what is that? That's 2x, right? 2x plus, what is this denominator missing? It's missing this factor, x plus 1. X plus 1. Can we multiply that? What is 5b times x plus 1? That's 5bx plus 5b. Now notice there's really no common factor between the top and the bottom, so you just have to leave that expression that way. So keep that in mind, especially when you have a binomial. So it's a binomial factor. All right, I'm down over here to the left. I'm looking at this problem. It should be a little bit easier to do now. So we're adding common denominator time. Okay, again, you could do it like I did at the top earlier and multiply by a 1 and multiply by a 1. But I'm going to work it this way. 2x times 3 is 6x. That's the common denominator. Now, what is this factor missing? This factor is missing a 3. So 3 times 3 is 9. plus. Now, I'm not putting that in a power position. I'm just making a note of it to keep track of. All right, what is this factor missing? Or what does this factor need to be multiplied by to become this term right here? That would be 2x. So 2x. What do I do with the 2x and the 5? I multiply 10x. Okay? Now, you may be tempted to try to divide out here, but you cannot. Let me explain that. 4 plus 2 over 2. What is 4 plus 2? 6 over 2, that's 3. But if I just mark these off like this, I'd have a 4. That is a no-no. No, 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 no in algebra working with fractions. All right. So now here we go. We're over here to this bottom part here, and I have a multiplication problem. Remember, multiplication problems, you can multiply straight across. 21 over 14. But wait a minute. I know there are factors that go into 21 and 14. 7 does. I could divide them out here, or I could be thinking ahead, and I could divide them out here. 7 into 7 goes 1. 7 into 7 goes 1. Now, 3 times 1, let's erase this. 3 times 1 is 3. 1 times 2 is 2. I can, sorry about that. I can do that, so keep that in mind. Now, I'm over here to this bottom problem. And what I'm doing is I'm multiplying. I'm going to have to move this up here so we can see it. I'm multiplying. Now, I could multiply them all out and put it under one fraction, or I could divide out before I multiply. So notice I have an x plus 1 factor. I can multiply a factor out. I have an x plus 2 factor. Okay, I can multiply that out. And let's just say you didn't know, and then you wrote, my answer is 2 over 8. But I'll know, that's not answer choice A, B, C, or D. So what you notice here, you're going to have to simplify that 1 and 4. The answer 1/4. Okay? So that's something you need to know in this lesson. And one other item, real quick here. I want to talk about a complex fraction. So how about this? 3 over 2 over 5 over 7. That is really 3 over 2 times 7 over 5. It's a fraction that somebody wanted to make complicated, okay? A complex fraction. This, I messed up. 3 halves divided by 5 sevenths means 3 halves divided by 5 7/5. I said that wrong. I wrote that wrong. I should redo that, but I'm not. So 3 halves divided by 5 sevenths. However, we know from working with fractions, that's the same thing as 3 halves times 7 over 5. Okay, 21 over 10. Now, last thing that I want to do is a short division problem. 3x squared over 4y cubed divided by 9x over 8y squared. Well, let's see. I need to change that to a multiplication problem, right? 3x squared over 4y cubed times 8y squared over 9x. Now, we could multiply it all out, but no, we're going to think ahead. Let's see. 3 goes into that 1, 3. I've got an x here, and I've got an x here. I would write it up there, sort of out of the way. I've got numbers 4 and 8, blah. Okay, and then I've got a y cubed and a y squared. That's really y times y over y times y times y. You may ask why. That's a good question. But notice how over here, y squared is y times y. I got 3 y's. So if I divided them out, wouldn't I have a y at the bottom? Okay. Wouldn't I have one of these y guys at the bottom? Not a y's guy, but a y guy. A y factor. So I'm going to go like this, this, and that. And then what is my last expression? It's going to be what? It's going to be 2x over 3y. All right, so that's a little quick intro to some of the skills you need to be able to go through to do that. Hope this helps. Thank you.